All right, now we're going to go through and do some examples of trigonometry questions. But first I want to show you an easy way to remember which is which. And so we talked about last time how the sine was the relationship between the opposite side and the hypotenuse. We talked about how the cosine was the relationship between the adjacent side and the hypotenuse. And then we talked about how the tangent was the relationship between the opposite and the adjacent side. Now remember, these are all with right triangles, and these deal with the angle. These ratios here are in reference to a particular angle. And so if there's any particular angle in a triangle, for example, maybe we're looking at this angle right here, then the tangent of this angle deals with the opposite side here and the adjacent side. If you move the angle, then you're dealing with different sides. So an easy way to remember this is an acronym called SOHCAHTOA. It's something that anybody who's studied trigonometry should know. And it comes from the sine being the opposite in the hypotenuse. That's the SO part. The cosine being the adjacent in the hypotenuse. And then TOA, tangent, being the opposite in the adjacent. And so this is an easy way for you to remember which trigonometric ratio is which. So now I'm going to use this in some examples here. So the first example here I have, it asks for us to find the sine of an angle. And we should be able to do that using the acronym that we just looked at. So the sine of this angle, if I get my cheat sheet out, I know that my sine should be the opposite over the hypotenuse. So maybe we should leave this out for ourselves. So since the sine is the opposite over the hypotenuse, you should look at this triangle and look for the opposite side, and then look for the hypotenuse. And so, again, remember, sine is my opposite over my hypotenuse. So if I look over here, since the sine of C, this should be my opposite side over my hypotenuse. Now you have to know which side to look at. So since C is here, the opposite side is 18, and the hypotenuse is 30. So the sine of C should equal the opposite side, which is 18, over the hypotenuse, which is 30. Now you could reduce this, divide them both by 6, and you get 3/5. It asks us to round to the nearest 10,000th, and so this is approximately equal to 0.6. All right, the next one asks us to look at the cosine of an angle. Now remember, the cosine of an angle, according to what we wrote down before, is the adjacent over the hypotenuse. And we remember that using SOHCAHTOA. So if I actually write that out, a lot of people will do this when they do one of these questions. They'll write out SOHCAHTOA. And then we know that we're being asked for the cosine. So I'm going to look at this part. So the cosine is the adjacent over the hypotenuse. So with reference to x, which is the angle that it's asking us to look at, the adjacent side is 21. Now you might think that 29 is the adjacent side, but since this is across from the right angle, it's actually the hypotenuse. And so the adjacent side is 21, and the hypotenuse is 29. So if we figure out what that is, 21 over 29, that should come out to 0.7241. So this is 0.7241. So, I mean, really, we should write out our answer. So the cosine of x is equal to 0.7241. Cool. If we look at the next one, which asks us to find the tangent of an angle, which is 7 I've got here. Now, it looks like the same triangle. It's just being rotated a little bit. And so I noticed the side lengths are all the same. If I do this one, I need to look at z. And so, again, since I'm looking at SOHCAHTOA, my tan is my opposite and my adjacent side. So when I look at the tan of z, I'm looking at the opposite side, which is 21, and I'm looking at the adjacent side, which here is 20. So that means the tan of z should be equal to the opposite, which is 21, over the adjacent side, which is 20. And when I do the division on that, 21 over 20, I get something that's a little bit more than 1. I get 1.05. So this is approximately equal to 1.05. So the tan of z is approximately equal to 1.05. Cool, let's go to some ones that actually ask us to figure out what the side of a triangle is. So here, if you look at 11, the instructions are to find the missing side, round to the nearest tenth. So I need to find the missing side of this triangle. It's asking us to find x. So I need to know what I should use to relate these two sides together. Usually I would try and use something like the Pythagorean theorem, right? 11 squared plus this squared equals that squared. I don't have enough information. So I'm going to use trigonometry. So since I'm looking at this angle right here, and I want to involve this side and this side. This is the information that I know, this is the information that I want to know, and this is the information that I have. So if you try and involve all three of those, looking at this angle, I have the opposite side, and I have here the hypotenuse. Now again, I know it might look like the adjacent side, but remember that the adjacent side to 38 is here. The hypotenuse is opposite the right angle. So then I'm going to set up my trigonometric equation here. I know that the opposite of the hypotenuse is sine. So that means the sine, and we abbreviate that with sin, of 38 should be equal to the opposite over the hypotenuse. So this is the equation that you can set up. Now remember that last time when we talked about how trigonometry works, this sine of 38, there's actually a table that we could look at, and we could look at the degrees and go all the way down, and we could figure out what the sine is. These have already been figured out by people over time. But we don't want to do that because it would take too long, and we have technology that's going to make that a little bit easier for us now. And so if you look on your calculator, there's actually a sine button. If you look down, if you look right actually in the middle, you've got sine, cosine, and tangent right here. And so these are buttons that are going to allow us to skip the table, basically. And so if I show you here, and I needed sine of 38 we needed for our question. So if I hit sine of 38, then that comes out to 0.2964, I guess I've got. So 0.2964 equals 11 over x. Now this is just a proportion. I should be able to solve this. And so if I multiply the x over, x times 0.2964 equals 11. If I divide by 0.2964, 11 over 0.2964. If I divide that in my calculator, I end up with 37.11. Now if I look at my triangle, that could make sense. I've got my hypotenuse here, which should be bigger than my side here. But that seems a little bit big. I looked back on my calculator now. I'm really glad that this happened. Your calculator has two different modes for degrees. And so if you see right here, there's a mode button. If you hit this mode, when you do these questions, you need to make sure that you're in degree mode, because we're using degrees with our trig here. If we use what's called radians, which you're going to learn later, you're going to get an answer that doesn't necessarily make sense, which is why when I looked at my answer and I saw 37.11, that seemed a little bit strange to me because that's pretty big given the numbers that I have on my triangle. So I'm going to go over here, change this to degree mode, and then I'm going to quit out of this. Now when I do sine of 38 again, sine 38, I'm going to get a different number. So I've got 0.6157. So I should replace that in my question. 0.6157, 0.6157. I'm really glad that this happened because it happens all the time to people when doing these questions. So I've adjusted that in my question. Now my final answer, of course, is going to get adjusted. So it's not going to be 37.11 anymore. If I look at what it should be, and I do it on here, 11 divided by 0.6157, oops, 11 divided by 0.6157, I end up with 17, and it asks us to round to the nearest tenth, so 17.9. This makes a lot more sense when you look at the triangle that we started with.